Okay, this is textbook EDD, problem 19.1. It's called a mounting bracket, and let's bring it into the screen here. So 19.1, mounting bracket, 0.23 thick, so they are not giving you a gauge, but we will talk about that. And we have a simple-ish looking U part, has a bend radius here, 218 to 281. Some holes with their tolerances. If you look at this tolerance here, it is 6.656 over to 6.593. That is a limit dimension. So that gives you the minimum limit, how small it can be, to the maximum, which is on top. So usually the larger one is on top of the smaller one. And it gives you a tolerance range. If you were to take these two numbers and to take the high one, subtract it from the low one, you would end up with a number, about 0.063. You would take that 063 and divide it by 2, add it to the low number, and that will give you the mean dimension, or the middle. Okay? And that's how you calculate a mean dimension. So if you go over here to 2.031 minus 1.968, and if you subtracted that, divided it by 2, you would end up with 2 inches when you round to 3 places. Okay, this dimension also, figure it out what it's going to be, its mean dimension, and then this dimension here, 3.531, the mean dimension of these two is 3.500. Okay, so those are limit dimensions. The ones shown in rectangles are your basic dimensions. So 5 inches, it should be 5 inches. When you are drawing these parts, if you're given these limit dimensions, you will always draw them to the mean size. Okay, so you have to do some calculating. So again, this one here would be 6.625. This one here would be 2 inches. This here would be 3.5 inches. I don't know what that is. You have to figure it out. This 416 over 396. Figure out what the mean is. The whole should be that size. 2 different ways to draw this part. Okay, so we're going to slide it off to the side again, and you should have it open on your secondary screen so you can refer to it. One of the first things you have to make sure when you're drawing in sheet metal, that sheet metal is actually open. So if it's not, right click here and go down. It's all in alphabetical order here, sheet metal. Make sure it's turned on. And the first way we're going to do it, we're going to do a base. So I believe I'm going to do it with a top view. So top, I'm going to sketch. I'm going to do a center rectangle. Escape and smart dimension. Again, we know we've already figured out it's 6.625 long. And it is 3.5 wide. I go to an ISO view. Okay, we also know from the drawing that it is 0.23 thick. So now, unlike features here where you're doing an extruded boss, you're actually going to go here, and it knows it's sheet metal, and you are going to put the thickness in. Okay, so in this case it's 0.23. So we'll put 0.23, and I'm going to go towards me, so I'm going to reverse the direction. And then the K factor, you can use bend table, K factor, bend allowance, so on and so forth. Okay. Generally, as a rule of thumb, I set the K factor to half of what the thickness is. So right now it's set to 0.5 of the thickness. All right, and I hit the happy check mark, and there's my base piece of sheet metal. So I'm going to save this on my desktop, but you guys know you're supposed to save it on your flash drives or in your cloud or something like that. So this is EDD 19.1. I'm going to put version A. This is version A of how we're going to do it. Okay. So the next thing we have to do is we have to create a flange. Okay, so you're going to select an edge, right? And it's going to give you different options, right? So if I go to my right view, I can see the different ways that it is allowed to bend. Okay, so if I go over to the menu You can see it goes to the outside, goes to the inside, right? All the different ways that it can be done. But if you look at the drawing, the 3.5 inches is to the outside of the part. Okay, so we have to leave it in this position. Now its overall height, okay, is 2 inches. So let's type that in, 2. Okay. And what we're going to do quickly is we're going to go to the right plane. Actually, we'll try evaluate first. We'll evaluate, measure. We'll measure from this surface to this surface. All right, so Y is exactly 2 inches. That's what it's supposed to be. Okay. So I have drawn this. Let's go to ISO again. I've drawn this in a center rectangle. Being that it is drawn that way, I can also say, hey, you know what? This is a mirror image. Now, sheet metal will or will not let you mirror it. Okay, it all depends. So here's the front plane. I'm going to mirror it about that. I'm going to hit mirror, and it's going to say, what do I want to mirror? Go into my design tree, and I'm going to say this. It gives me a nice preview, right? I usually like to see a full preview. Make sure that button is checked over here. Happy check mark. Okay, it's a nice simple bend, so it should mirror, no problem. Another reason I did center rectangle, if you look at those holes, they are 5 inches centered. Okay. So if I go to my top view, right, and now we have to do a little math. So let's see here. We'll bring up the calculator. Right, so we know that it is 0.416, right, minus 0.396, right, equals a number. Whoop, I think I did something wrong there. Let's clear that. 0.496. 416. Oh boy. 16 minus 0.396 equals a number. So divided by 2 equals a different number. Now we add it back to the 396. Right? So it's a 406 diameter hole. That is its mean dimension. A mean dimension is not somebody who picks on you. A mean dimension is in the middle of the tolerance zone. In this case, it's a limit dimension, so it gives you the lower and the upper tolerance. Take the upper, subtract it from the lower, or subtract the lower from the upper, divide it by 2, add that division number to the lower, and that will give you the mean, which is 406, and that's pretty much a standard drill size. And then I'm going to select this surface, but I'm just going to do a cut through, right? So again, it picks up the center. All right, we know it is 0.406 because we just calculated that. All right, and then I always like to do a center line from the origin to the center of it. Escape. And we know that it's 5 inches, so I can do 5 divided by 2. Let it do the math for me. I go to an ISO. All right, and then I'm going to do features. This is interesting. When I do extrude cut, because it's sheet metal, I can link it to its thickness. So no matter how thick I make it, it will always make sure the hole is cut all the way through. And then if I go to my top view again, all right, I can do a mirror again about a plane, so we know it's from the right side. What do I want to mirror? I want to do that cut extrude. Nice preview. Happy check mark. All right, little ISO. We can see they're both there. Save and save often. Okay, and that's the whole part. Now, as I've shown you in a previous drawing, most likely last cycle, if I go into flat pattern and I open it up and I right click, I can unsuppress, and it will unfold my drawing, right? As the drawings get more complex, you should get in the habit of chewing the flat pattern every 2 or 3 features to make sure everything is working correctly. The last thing you want to do is have a design tree that's 30 or 40 items long, and then you try to flatten it at the end and the thing explodes on you. Okay, so it is a good habit to check every 2 or 3 times you do something to make sure that it's still going to flatten, especially when you start getting into really crazy bends that are going on. Okay, so now we have the part. All right. In this drawing, I would like you to create the exact drawing that they give you there. Okay, so make sure let's bring it back in here. Let's make sure all the tolerances are done in limits and things like that. Okay, and let's also make sure that the flat pattern is here, but there's only one difference. In the flat pattern, generally in industry, you do not need to fully dimension it. 99% of the vendors that I work with, you can send them a SOLIDWORKS file like this to work with for one thing. And let's just do a quick B size, okay? And we'll put it on here. All right, so let's do this, and we're going to do, let's see what views we get here. There's a top, right? As you know, I like ISOs, and a lot of industry people like to see ISOs because it makes their life easier for the guys on the shop floor if they're getting a little bit, especially if they're new to the trade of sheet metal. It makes it easier for them to see what you're looking for. I usually like to shade those also. Okay. So we have this. Okay, all the dimensions as required, but I'm going to throw one on there, just the overall length. Okay, so 6.625. All right, but we have tolerancing. So what kind of tolerance do you want to do? Oh, I want to do a limit. Right. Well, right now it's 6.2625. Right. But we have to change these. I'm pretty sure it was 31. Right. So I got to do my upper and lower. Right. And you see it's 494. So let's make that 0.03. No, doesn't like that. Let's go 0.0315, which is actually the real dimension. It's still rounding it up a little bit strange, but you got the 694 to 656. Pretty close. Okay, that's your limit dimension, top over to bottom. Do that with the rest. So now you know about this limiting thing over here. Right. So you have different types of tolerances. So you have none. Oh, a basic, right? Let's do a basic quick. Let's do another smart dimension. Let's go hole to hole. All right. And I'll drop them in there. Zoom in. All right. And you see how it's jumping to positions, okay? Because if you set this up right, it should sort of find itself. I usually like to offset them. This is a basic dimension, so I just click this, click basic. Ah, the rectangle's there, right? So you don't have to draw anything fancy. What else do we have? What else do we have on this drawing? We have a lot of things going on. I want to insert a drawing model. Same thing. I want to do a flat pattern. Okay, and it'll take a second. There it is. Okay. It will tell you at the center of the radius where to bend this. What I generally do is I will go into my smart dimensions. I will do an ordinate or a horizontal ordinate. I usually like to do upper left, and I will pick the bend radii. Okay, and then I will go into smart dimension and do a vertical ordinate and 0. All right, and then the overall. Okay, and then somewhere in here, you're going to have to put the thickness, or you can put it in the materials. All right, so but the material is called out as 5086-H32. That should be here in the material. Finish, I see no finish required, so there is nothing that you need to do there. You have to fully dimension it. Flat patterns, generally I do not give out all the information that they do in their drawing. I will give out the bend center lines, okay? I will give out the overall dimensions, and this should be enough information that and the thickness and what type of material it is to tell whoever's making it how to make it, okay? How much material they're going to use, okay, to manufacture this little U bracket. So, along with the rest of it, dimension this fully, okay? Next thing, what do we have on there? Oh, we have some geometric dimensioning and tolerancing. So how are we going to get that in here? Let's see, we have a B that's going off of this edge up here. And if I go into geometric dimensions and tolerancing, I don't want to do that. What I want to do is I want to go into a datum. All right, and the first one that comes up is A. So if I select that edge, right, the A would come out. If I don't want A, I can double click and say, you know what, this first one's supposed to be B. Everything's in capitals, right? And then there's a C along this line, so you can put those flags, okay? You can see on the drawing, you have, like I said, you have datum B, A, C. Make sure they're off the right edges, okay? We will get into GD and T much further down the road, okay? But this is telling me that this is a positional tolerance, okay, for the diameters of 30 thousandths. And once we get into GD and T deeper, you'll get a better understanding of what that means. For right now, just emulate this. Use the GD and T information here. Play with it first. See if you can figure it out. Remember, it's CAD. If it doesn't come out right, hit undo. Do it again. So all those things are in there. That's basically the drawing that I'm looking for with all the other dimensions, okay? So don't forget those. The flat patterns, I'm a little more loose on those because working with the guys in industry, especially here local in Milford, they generally want to see at least the overall sizes. The overall sizes also have one other important thing. I could take this drawing. I can go up here and go File, Save As, okay? And I can save that as a DWG or a DXF, which is very popular still. And when I do that, sometimes the scale of the whole drawing might get a little bit shifted, okay? So by giving an overall length of the blank, all right, and your dimensions, especially in your 3-view drawing, those guys can then open up and say, hey, you know, I'm going to measure from this line to this line now that I've imported it into another software. Popular software for sheet metal is called TOPS. I'll bring it into TOPS and say, oh wow, this dimension came in at 6.613 instead of 813. So it messed with the overall scale ever so slightly. So with a little quick math, I can scale all these drawings up a little, okay, in the TOPS software to get back to the 6.813 and make sure it's the right size. So that's another reason you put some overall dimensions in here so they know that the software they've brought it into is going to make the correct part. Okay, some guys don't do that, and it ends up costing them money because they did not check to make sure that the file that was imported is actually the size that they use. If that company uses SOLIDWORKS, you can also send your solid model along with a drawing. That'll make their life easier. Send the DXF. Another option in here also is always nice is Save As. And in your drop down you can do an Adobe portable document file, or a PDF is what it's called, okay? And that's another nice little thing that they can be read just about anywhere in the world. So that is version 1 of how to do this drawing.